In this video, we are going to solve one problem on the week 5 homework assignments for question 75 on the MyMathLab assignments. We are given a problem where a point on the terminal side of an angle theta in a standard position is 4 minus 2. Find the exact value for each of the 6 trigonometric functions of theta. So the first step is you need to draw the diagram at a standard way when solving any trigonometric functions for this type of questions. So first thing is you need to draw the diagram. We know that the theta has the location of 4 and minus 2. So 4 is on the x-axis, 1, 2, 3, 4. And then minus 2 is on the minus y-axis. So that point is right here. And now if we connect the line to that, we should have the angle theta here. Okay, so this is the angle that we are looking for. Now, how do I find the exact value of the 6 trigonometric functions of theta? Now, the way we do that is we can make the triangle at this point, because this is the point that we are given, 4 and minus 2. So the height right here has 2 units, and then we also have the length of the base here is another 4 units. So in order for us to figure out the value of the hypotenuse right here, remember we use the Pythagorean Theorem. Let's call this is the z value. Okay, so the z square is equal to the other 2 sides of a rectangle, triangle square, adding together. And if I do that, I have 16 plus 4, that gives me 20. So z squared is equal to 20. So z is the square root of 20. And I can simplify 20 is 4 times 5. And the square root of 4 becomes 2 outside. 2 radical 5. So the value of z is 2 radical 5. So I can erase z and I can put 2 radical of 5 for the length of this segment of the triangle. Okay, we are ready to find the first trigonometric value, which is the sine value, sine of theta. Remember, this is the horizontal is the sine axis, okay? The vertical, the y, is the cosine. Now recall that if I draw the unit circle, we know that the this y-axis is your cosine, this x-axis is your sine, and the tangent is this one. Tangent, okay, this line, and this is a particular angle right here. This is a standard picture for a unit circle. Now to find the sine, remember sine of theta, sine is the opposite divided by the hypotenuse. So sine of angle, which is the opposite of the angle, is 2 divided by the hypotenuse, which is 2 radical of 5. Now remember, this is the point, the given point, this given location, and sorry, I make a mistake right here. I mess up the sine cosine. The horizontal is the cosine, the vertical is the sine. So this is the sine, this is the cosine. Okay, Alright, so we know that this is the point that we are given, and this point, if we are looking for the side, and the side axis is this vertical axis, and this point happen to be on the negative side of the side. Therefore, even though we use the formula right here, but according to this figure, the value of this side should be negative because this point is on the negative y-axis and the y-axis is a side. So we are in a negative region. Therefore, we don't forget to include a minus side here because side should be negative because it's down here and this is a side. And you can simplify 2 and 2, they cancel out. You have minus 1 over the square root of 5. If you multiply the square root of 5 on top and the bottom, you get the square root of 5 and 5. And this is a simplified version. Remember, we are trying to not let the square root to be in the denominator, so we are trying to move it to the top. Now to get cosine, we take the adjacent, divide by the hypotenuse. Cosine, adjacent is 4 units, divide by the hypotenuse 2, multiply the square root of 5, and this point cosine, so we project this on the cosine axis, and this is the positive cosine, so this is a plus, so that's good. 4 divided by 2 give me 2 on the top, and then I multiply the square root of 5 on the top and the bottom to rationalize the denominator, and that is my answer. Now to find tangent, tangent is equal to sine over cosine, and sine, we know that we got the value of sine, which is minus the square root of 5 over 5, and then cosine is this value 2 the square root of 5 over 5. Now this is a complex fractions. When you are dividing the fraction by fraction, we can turn them into the multiplication and then take the reciprocal of the second fraction. Okay, and now in here I see that I can cancel out the square root of 5 and also 5. So all I get now is minus, and then on the top it's 1 over 2 at the bottom. Okay, so we cancel everything, leaving minus 1 on the top and 2 at the bottom. So this is my tangent value. And then we have sine, cosine, tangent. And then the next one is we can find cosecant. Cosecant is 1 over sine, or the reciprocal of sine. All we do now is we flip the sine. 5 go to the top, the square root of 5 go to the bottom. Okay, and then I can simplify this further by multiplying the square root of 5 on the top and the bottom. That's give me 5 at the bottom, and now I can cancel out of 5, and that's leaving me to have minus the square root of 5. So that is my cosecant, and I can find secant. Secant is also 1 over cosine, and cosine is this value, so we take the reciprocal of that. So I bring 5 to the top, and then 2 the square root of 5 to the bottom, and I the square root of 5 on both top and the bottom. Right, the square root of 5 and the square root of 5 give me 5, and multiply the square root of 5 on the top. I have that, and now I can cancel out the 5, and I can get the simplified version of that, equal to 2. And we have everything now. The last one is cotangent. Okay, cotangent is equal to 1 over tangent. And tangent is right here. Tangent is right here. So you take the reciprocal of that, which is minus 2 over 1 or minus 2. And that is the answer. So we have sine, cosine, cosecant, secant, cotangent, and tangent. So the best thing that you should do for this type of problem is to find the sine, cosine, and tangent, and then after that you can figure out the cosecant, secant, and cotangent easily after you get sine, cosine, and tangent. And that's how you find this problem.